this video, we will be talking about chapter 10.5 of the ebook Applied Statistics for Business and Economics. I think that's the name of the book. But yeah, this is just a continuation of what we've started before, and yeah, let's get started. These are the formulas that we'll be making use of. The P variables, those are basically the sample proportions. We need these two values, as well as the PC, which is basically the pooled proportion, the combination of all number of successes divided by the combined sample sizes. And that ultimately goes down to this test statistic formula. This is for the equality of proportions, and that's exactly what this video is about. So example 10.4 has been solved already. It's already a giveaway. So more on that in the next practice questions to come. We're here at 10.20, and we'll be proceeding to the next practice questions until we reach the next chapter. That is for the next video, all about 12.1 and more coming soon. But for now, let's focus on the first question, the first practice questions. So 10.20, calculate the test statistic for a test of equal proportion populations. So what is your conclusion? So P1, basically what was mentioned earlier, P is generally X over N, successes over total sample size. So yeah, the formula is still the same even though it's P1 and P2. So proceed. I just rewrote everything that's given here, and yeah, substitute the values. For P2, it's X2 over N2, 703 and 760. And then okay, let's go 228 over 240. That is 0.95. Then 703 over 760. That is 0.925. For the PC, we have 228 plus 703 divided by 240 plus 760. So what happens next? 228 plus 703 over 240 plus 760. Based on the calculator, the answer is 0.931. So let's make use of the formula. It's again zcalc. The test statistic for proportion is x1 plus x2 over n1 plus n2. Easy as that. You can easily memorize it. So for x1, it's 228, x2 is 703, and then n1 and n2 is 240 and 760 respectively. Oh wait, shoot. This is the pooled proportion. We just did that earlier. For zcalc, the statistic for equality of proportion is P1 minus P2 over PC times the quantity 1 minus PC times 1 over N1 plus 1 over N2. And then the entire denominator is under radical sign. Did I get it right? Okay. Yeah, good so far. I think I've memorized it. Hooray. P1 is 0.95. P2 is 0.925. Then divided by PC, which is 0.931, times the quantity 1 minus 0.931 times 1 over, what's our N1? It's 240 plus 1 over N2. N2 is 760. And don't forget the radical sign. Okay, according to the calculator, the answer is The answer is 1.332 if you round it off to just this way. And then, yeah, I think this is already the answer. This is the test statistic. So you might need another page for the next two problems. Computations always require a lot of space. So for letter B, again, we look for P1 and P2, and then we look for PC. So for P1, x1 over n1, that's 36 over 80, or that's equal to 0.45. For P2, we have 66 over 120, x2 over n2, that is 0.55. For PC, we have x1 plus x2 over n1 plus n2. We then have 0.51. So these are the three variables that we'll be using for the ultimate formula. Zcalc is equal to P1 minus P2 over PC times the quantity 1 minus PC times quantity 1 over n1 plus 1 over n2. Everything in the denominator is under a radical sign. So P1 is 0.45, P2 is 0.55. Below, we have 0.51 times the quantity 1 minus 0.51 times the quantity 1 over n1 plus 1 over n2. So what's the answer? I think we have negative 0.934 as the final answer. Let me just double check. I just skip this part of the video if you want to move forward as you're supposed to save a lot of time. I think, wait, the answer is this one, not this. Negative 1.386. If you put the calculator this way, then the answer was the one a while ago. But without it, the answer is this. Okay, let's move on. Letter C. So given we have to look for P1. P1 is 52 over 80, x1 over n1, that is 0.65. For P2, that's equal to 56 over 70, that is 0.8. For PC, x1 plus x2 over n1 plus n2, we have 0.72. Okay, let's solve for the Zcalc test statistic for equality of proportions. We have P1 minus P2 over the square root of PC, which is 0.72, times the quantity 1 minus 0.72 times the quantity 1 over 80 plus 1 over 70. Okay, what is the answer? we have negative 2.041. Okay, let's move to 10.21. Calculate the statistic and p-value for a test of equal population proportions. Okay, I'll just copy the important details. Kindly skip this part to move on to the actual computation. I'll just list them down. Okay, so let's do this part first. So for letter A, look for P1 again. That's 28 over 336. We have basically 1 over 12. And for P2, we have 14 over 112. That is 0.125. For PC, we have 28 plus 14 over 336 plus 112. The answer is 0.09375. Now, the formula, zcalc is equal to P1 minus P2 divided by the square root of 0.09375 times the quantity 1 minus 0.09375 times 1 over 386 plus 1 over 112. Okay, what is the answer? Okay, the answer is 1.310. There is an answer key for all odd numbered exercises in this ebook, so I'll just make sure I'll double check. While we wait for the ebook to load, let's answer letter B. As much as I really appreciate the information in the ebook, the software is just really freaking slow. So I apologize for that. Yeah, let's answer letter B. So P1 is equal to 276 over 300. That's a 0.92. For P2, it's 440 over 500. That is 0.88. For PC, we have 276 plus 440 over 300 plus 500. That is 0.895. Okay, Z-calc is equal to P1 minus P2 divided by square root of 0.895 times 1 minus 0.895 times 1 over 300 plus 1 over 500. .787 Z-calc. Okay, this is the answer for letter B. Might as well answer for letter C, so that we can check them all at once. So P1 again is 35 over 50, that is 0.7. P2 is equal to 0.56. For PC, that is equal to 35 plus 42 over 50 plus 75. 0.616. And then the Z-calc is equal to P1 minus P2 divided by the square root of 0.616 times 1 minus 0.616 times 1 over 50 plus 1 over 75. So this is 1.577 Z-calc. Okay, the ebook should work by now. These are problems of 10.21. So for letter A, answer is negative 1.310. That's correct. For letter B, we have 1.787. and 1.577. Exactly, it's the same as the answer key. Okay, that's good. Let's try out this one. Find the sample proportions and test statistic for equal proportions. I'm not sure though how to find this one, but this is what we'll do primarily. Does it have the same instructions as 10.23? They're different. I can guarantee you that we'll be finding this, but not this one. So, letter A. We're given A is equal to 0.05. This is a two-tailed. And then we have x1 equal to 40, n1 equal to 100, x2 equal to 30, and 2 equal to 100. And then for letter B we have okay. So for letter A, as usual, find the following. Okay, so we found all the three variables. Let's use the actual formula now. Again, let's recall that it's P1 minus P2 over PC times the quantity 1 minus PC times 1 over N1 over 1 over N2 plus 1 over N2. Denominator has a square root. Sorry, a radical sign. The answer is 21.978. So next to letter B, as usual, Okay, so that's for letter B. Let's move to C. Alright, so 1.638 is for letter C. Let's move on to 10.23. Find the test statistic and do the two sample test for equality of proportions. Hang on. Oh, okay. I think I'm understanding something right now. This is Z-Cup, so apparently we could make a conclusion using hypotheses. We'll be doing that here. Two sample test. Okay, so this is where we actually start the actual computation. So, okay, we're already given the p variable. Okay, so we have step 1. For test statistics for equality of proportions, we have something like this for HO and H1, the null and alternative hypothesis respectively. I think it's something like this. And then because this is a left-tailed test, our inequality signs will be like this, I think. Yeah, and then you just put 0. So let's look for the critical z value. We're not looking for a t value because the formula for the test statistic for equality of proportions is it basically involves the z table, not the t1. So critical z value we look for using the standard normal distribution process. We have the a, we need the a and the fact that it's left tailed. So yeah, I hope you have your z table with you. We're gonna make use of it more often. Let me just resend it. Okay, so these are basically the common z tables, z values, and it's from the ebook itself. I just copied it using my own handwriting. So given that we have 0.01 and the fact that it's right-tailed, we get positive 2.326. Okay, more on that later. So let's move to step 2. We reject HO if Z-calc, then just copy the alternative hypothesis inequality sign and then copy the Z value. Okay, now let's go to the computation. For the computation, again, the formula is Z-calc is equal to P1 minus P2 over the square root of wait, we haven't calculated for PC yet. PC is P1 plus P2 over N1 plus N2. That is equal to what? Let me get my other scientific calculator. I'll be back in 10 seconds. Okay. So we basically have 0.0084. So PC times the quantity 1 minus PC times 1 over N1 plus 1 over N2. And then P1 again is 0.30 and then minus P2, that's 0.54 over PC is 0.0084 times the quantity 1 minus 0.0084 times 1 over 50 plus 1 over 50. Okay, for the Z-calc, we have negative 13.148. Okay, let's just check if the answer has the same answer as mine. 10.23. Oh wait, before that we haven't done the fourth step. That is the resolution. Let's try to visualize it on this kind of graph. And then 2.326 is here, the critical z value, and our z-calc is somewhere here, negative 13.148. And this is the right, no, so never mind. This is a left. Oh wait, shoot. This is a left tilt test. So the symbol of the critical z value should be negative. My bad. So yeah, it's supposed to be here, negative 2.326. And in the left tail test, this region is reject, and this region is do not reject. So apparently our z-calc is in the reject region, therefore we reject HO, or the null hypothesis. So that's for 10.23. This one is correct, but for some reason my z value isn't the same. This one is also correct, the z value, and according to the ebook, z is equal to negative 2.431. I'm not sure if it's yeah. Anyways, you can't blame me. Teacher didn't teach everything. Okay, for 10.24. Oh wait, we haven't even done letter B and C yet. Okay, so for letter B, we have A is equal to 0.10. This is a two-tailed test. We have B1, which is 0.45. We have N1, which is 80. B2 is 0.25. N2 is 48. For letter C, we have A is equal to 0.05, and we have a left tail test. B1 is 0.20, N is 80, B2 is equal to 0.32, N2 is 75. Okay. Let's go with two-tailed. B1. Oh wait, we already have P1 and P2. So let's solve for PC. PC is x1 plus... I can see where I got... I can see where my mistake is. Yeah, I can see it very clearly. I'm not given x1 and x2, but then those are the values that I placed in the place of x1 and x2. Shoot. So yeah, PC is wrong. The value of PC is wrong. P1 is equal to x1 over n1. So given 0.30 is equal to x1 over 50. This is basically simple algebraic manipulation. X1 is equal to 50 times 0.30, that is 15. X1 is 15. Let's find X2. Okay, for X2, P2 is 0.54. X2 is just like that, and N2 is 50. 0.54 times 50 is 27. Okay, good call. At least we can see now why my z-calc value is not correct. So PC wait, we need space for the computation. Let's move this here. Okay, so for PC, it's x1 plus x2, that is 15 plus 27. What is n1 plus n2? That is 50 plus 50, that's basically 100. In the calculator, the answer is 0.42. So with a PC value of 0.42, we sub these ones into this. There you go. Now the calculator says that it's negative 2.431, which is exactly this one. Good call. Good call. So let's visualize it again in the graph that we've drawn a while ago. This region is negative 2.431. Negative 2.431 is less than negative 2.326. So it's here in this region. Still reject HO. Okay, let's go back to letter B. Good call. Let's do the same process here. Okay, now we can calculate for PC. Okay, that is the PC value. Let's start with step 1. Step 1, HO, H1, pi 1 minus pi 2. This is a two-tailed test, so the inequality signs are equal and not equal sign for null and alternative hypotheses respectively. And then we just put 0. Let's find the critical z value. So because this is a two-tailed test, a will be a over 2. That means 0.10 will be 0.10 divided by 2, which is 0.05. So it's 0.05, and the fact that it's a two-tailed test, let's bring out the sheet a while ago. Okay, so we have 0.10, and it's a two-tailed test. It's this one, plus minus 1.645. Okay, good catch. More on this paper later. Critical z value. For step 2, reject HO if z calc is less than negative 1.645 or z calc is greater than positive 1.645. Just to reiterate, if you have a two-tailed test, this is how we write z calc always. So for 3, the computation, again, z calc is equal to p1 minus p2 over the square root of, what's this, 0.375 minus 0.375 times quantity 1 over n1 plus 1 over n2. For P1 and P2, they are 0.45 and 0.25 respectively. So just will write them that way. Okay, from the calculator, what is the answer? We have 2.263. C-calc is 2.263. Okay, and for step 4, what is our ruling? Need more space. Let's visualize using a symbol, using the graph, the hill looking graph, and then because this is two-tailed, this is 1.645 here, the other 1.645 is here, and then 2.263 is over here. In the two-tailed test, this region is a do not reject region. The right and left sides are reject. So, because 2.263, our z-calc is located in the region of reject, we reject HO. Okay. Let's check if I have the same answer as the ebook. And this is 10.23, letter B, 2.263, reject HO, and then critical value is plus minus 1.645. Very good. Let's go with C. You know what? Never mind. Let's not do that. Yeah, let's actually do it. One more page just for letter C. Literally takes one entire page, almost an entire page. Well, more than half, most likely, just to solve one single problem. Okay, anyways, this is ending. Let's look for x1 again and x2. Okay, so 0.20 times 80 is 16. X2, that's 75 times 0.32, that is 24. Now, let's look for PC. PC is x1 plus x2, so 16 plus 24, divided by n1 plus n2, 80 plus 75. So 0.258. So let's start with step 1. HO, H1, pi 1 minus pi 2 over pi 1 minus pi 2 again for alternative. Because this is a left-tailed test, our inequality signs will be like this. If I recall correctly, I hope I do. Yeah, it is correct. And then you put zeros, and then critical z value is gonna be, since this is 0.05, it's a left-tailed test also. Let's pull out our sheet again. This one. So it is a left-tailed test, and it's 0.05. So we have negative 1.645. Okay, good looking. Let's go with step 2. Reject HO if z-calc is copy the inequality sign of the alternative hypothesis and rewrite the critical z value, which is negative 1.645, and computation again, z-calc is p1 minus p2 over pc times the quantity 1 minus pc times the quantity 1 over no 1 over n1 plus 1 over n2. Denominator has an entire square root, and then p1 and p2, 16 minus 24. PC is 0.258 minus times the quantity 1 is 0.258, and then times the quantity 1 over n1 plus 1 over n2. So we have negative 113.75 or 76 to round off. What's our ruling for step 4? Let's find out. Visualize again. We have negative 1.645, and damn, this number is so far. This is negative 113.76, and this is a left tail test, so this region is reject. This region is do not reject. So we reject HO, I suppose. I really wonder if I got this correctly. Letter C. No, I got the Z-calc value wrong. Let's check this. This is correct. This is also correct. But this one isn't. I wonder why. According to the answer key, Z value is the Z calc is negative 1.706. I don't know anymore. I don't see anything wrong with the computation. Let's see if we got the x1 correctly. 0.20 times 80, 60. Yeah, I give up. It's your call now to find out why it's wrong, why this computation is wrong. Let's go with 10.24. I wonder how many problems we still have. 2, 3, 4, 5, 6. 6 more to go. I might make a part 2 since this is already too long. During the period of 1998. Before we read it, let's enumerate what we have to find. Okay. During the period 70 hurricanes. Okay, so 45 and 70. Oh wait, there's another mention, something mentioned earlier. 46. Wait, this is 46. Total hurricanes in the Atlantic, and then 19 of which struck the United States. 19. In the context, it says percentage hurricanes that strike the United States is increasing. So definitely the success in the sample, you consider them those that struck the United States. So 70 is n, x1, sorry, these are supposed to be sub 2. X sub 2 is 45. And then the critical value at 0.01. State hypothesis test whether something is increasing. Increasing is a keyword for right-tailed test. Now let's try step 1. Step 1 is HO and then H1. Because it's a right-tailed test, we put something like this, and then 0, 0, and then critical T. I think it's a T. No, it's a Z value. This is all about proportion, so we're gonna use the Z table all the time. So it's 0.01, and the fact that it's a right-tailed test, what is the critical Z value? Let's use this again. Okay, 0.01, and the fact that it is a right-tailed test. Okay. We have positive 2.326. Let's go with step 2. Step 2, reject HO if Z-calc is greater than 2.326. And then for step 3, the formula, I'm not gonna copy it anymore. I'm not gonna write it anymore. I'm just gonna copy paste. And then P1 minus P2. We haven't found P1 and P2 yet. P1, P2. For P1, we have 19 over 46. For P2, we have 45 over 70. That is 9 over 40. And then we have PC. That is 19 plus 45 over 46 plus 70. So that's 16 over 21. The reason I'm writing them in fractions this time, the decimals are a lot longer to copy. If you want accurate results and the decimals are just too long to copy, then just stick with the fractions. And then PC is 16 over 29 times the quantity 1 over n1, which is 46, 1 over n2, that's 1 over 70. So we have negative 2.435. this is a right tail test. Critical Z value is 2.326. 2.326 is here. And then negative 2.435 is here. So for our ruling in step 4, we failed to reject HO. This answer isn't guaranteed because it is an even numbered exercise. That means there's no answer for this at the answer key of the book. Okay, moving on. In 2016, wait. For letter E, can normality be assumed? I can't really answer that for now. I'm not really sure how to do it. So, yeah, I'm sorry. Okay, so this is definitely the success, number of successes. This is the year 2016. This is the year 2017. Sample of the same size. Okay, so yeah, 200, 200. A is 0.01. Okay. This will be the last question. We'll be making a part 2 for this. For the 4 questions remaining. Okay. Let's look for P1 and P2. Okay, so for the critical C value, let's pull out again our paper. .01, and it's a right tail test. It goes to positive 2.326. again. So, statement: reject HO if Z calc is greater than 2.326. And then for step 3, the computation. P1 and P2, that's 0.31, 0.26. PC, oh wait, sorry. And then 0.26. Answer is negative 2.279 or negative 2.28 to wrap it up. Finally, for step 4, let's write first the graph illustrated. So in a right-tailed test, this region is reject, this region is do not reject. So we fail to reject HO. Let's see if this is the same answer as the one in the ebook. The answer key 10.25. C is yeah, this is correct. Cannot reject, but it says that this is a close decision. I'm not sure what that exactly means, but yeah. Critical Z value is, it says here, it says in the ebook it's negative 2.326. I'm not sure why that is, but then this is a right-tailed test, so yeah, I'm not sure why the book says this one. That's just a heads up for you. Yeah. Okay, let's move to 10.26. Should I continue or? Yeah, I'll cut this video. We'll continue 3 more examples. 4 actually. 4 more examples. Thank you for watching.